Kentech Inc. has been creating conversational CNC programming software since 1986. Our mantra has always been that not every workpiece requires a complex CAD-CAM system nor a CAD-CAM programmer to create the G-code to machine the part. The differences between CAD-CAM programming and Kipware Conversational are stark. We're not saying that one is better than the other. What we're saying is they're different, and both have a place on a shop floor to help increase efficiency and increase output. In this video, we're going to demonstrate the programming of a simple part, the type of part machined on 99% of shop floors around the world every day, using both a CAD-CAM system, Fusion360, and Kipware Conversational. You can see from the drawing that we're taking 1.25" stock, turning it down to 5/8, grooving the back, and putting a 5/8 11 thread. As we go through the video, you'll see that CAD-CAM is basically a design tool. First and foremost, it requires a CAD drawing to create even the simplest program. Kipware Conversational is a G-code generating tool. It's designed to get the shop floor to the G-code, to the machine, to start machining the part, without the use or the need for a CAD drawing. We'll show you through the video that using Kipware Conversational to program the simpler everyday parts can lead to increased efficiency, less cost, and a better output for the shop floor. So here we're going to dive right into the CAD-CAM portion of the video, and here we're going to model the sample part so that we can create the G-code program. And again, the differences between CAD-CAM and Kipware Conversational is that everything has to start with a drawing in CAD-CAM. So the first thing we have to do is create the drawing. Now sometimes the customer may supply you with a CAD drawing, but if you search the internet, you'll find that a lot of customers complain about customer supplied CAD drawings and that they're not in proportion, features are in the wrong place, dimensions have been fixed rather than actual dimensions from the print. So sometimes there's a lot of rework that has to go into that CAD drawing before you can still create an accurate G-code program. So in this portion of the video, we're going to model the CAD drawing for the sample part, and we may speed up the speed of the video to show you how it's done, but not necessarily take up too much time drawing. Now I don't pretend to be a CAD expert, but I've been using CAD software since about 1990, and so I have a little bit of experience. So we're going to use that to keep that in mind as I create the drawing. So we're going to start in Fusion360 by creating a sketch. I'm going to choose a sketch on the XZ plane. And then what I'm going to do as I build the part is I'm going to go in and I'm going to create a cylinder first. I'm going to start from the back of the part. So the part is 1.25". So I'm going to make the 1.25" stock. And then I'm going to extrude this. Probably about 1.25", just so I have some stock behind the part that I'm going to create. And then I'm just going to continue to model the part the same way as I've done just there, going through the part you'll see in the video as we speed up the timeline a little bit. So there we have the part modeled. We've got the 5/8 thread, we've got the chamfers on the two ends, we've got the groove. So this is the part that we're going to machine, and now we're going to go to the machining portion of Fusion 360 to create the G-code program. So creating the drawing, creating the model for the part took us a little less than 10 minutes, which I think is probably normal. I don't think that's too fast or too slow. It's probably about average for someone with CAD experience to create the model that we need to create the program. Now here's just a little confusing part for me is I'm a machinist. I know how I want to make the part. I know the tooling that I want to use to make the part. But now I have to make 360 do this for me and create the G-code program based on how I want to machine the part. So let's see what's involved with that. So the first thing I have to do is I have to go and I have to change from the model to the CAM, and then I have to do a setup. So I have to tell the software how much stock I got. So we're going to tell it that it's turning. We're going to go to the stock and we're going to tell it that the stock diameter is actually just 1.25 inches. The length of the stock, I want to go just a little bit beyond this chamfer here, so I'm going to go 1.25 inches there as well. I'm going to offset this from the front. We're going to change the x-axis to go up and down like this. So now I've described the stock so that we can start to machine the part. So we're going to get into actual machining next. Actually, before we do this, we don't have any stock on the front of the part, so I'm going to go back into the setup. I'm going to offset from the front. I'm going to offset this 1/8 of an inch to take the material off the front, and now I'm going to increase the length of the stock because it's just barely at the end of this chamfer, so let's say 1.5 inches. Okay, so now I have my stock defined, have my diameter of my stock defined, so now I can start to machine it. So I'm going to go into turning. I'm going to face it first, and so I have to pick a tool. I'm going to use some of the standard tools that come with Fusion 360. This right-handed turning tool. I'm going to use flood coolant. I'm just going to kind of leave these defaults here just to get through the actual machining of the part a little bit quicker. So I'm going to say that's okay. So now I've faced it. I'm going to come in. I'm going to turn the profile. So I've selected all my tools and I've selected all my operations. A lot of these need to be really dialed in. This is just to kind of give you an idea of what the process would be like to have to go through, create the tooling, create the grab the tooling, create the tool path, and then you would post-process it out. Obviously, end up with a G-code program that you would send to the machine. So while some of these are not exactly perfect, it does give you an idea of the process that's involved. First you have to make a drawing, then you have to go through and select all these tools, select the stock, go through and create all of that information so you can create the G-code program. So this is going to conclude the CAD-CAM portion of the video. So in essence, we've created a G-code program we're going to send to the machine and machine the part. Now we're going to take a look at Kipware Conversational and see what the difference is to be able to create a program using the conversational menu. So to create the drawing, create the CAM portion of it, to create the actual G-code, probably took us about 20 minutes, 25 minutes to be able to do that. So now we're going to compare that, and at the end of the video we're going to kind of give you a breakdown of costs involved and how the 20 minutes, 25 minutes to create it using a CAD-CAM program reflects on how you could do it with Kipware Conversational. So this portion of the video is going to take into account creating the program using Kipware Conversational. And again, the big difference, one of the big differences is we don't have to create a drawing. So we're going to go right into creating the G-code. So we've eliminated the 10 minutes or so that it took us to create the drawing in Fusion360. The design is basically we're going to choose operations from the conversational screens. We're going to create cycles. We're going to put those cycles up in the tree, and then we're going to create a program that's going to link all the cycles together, create one big program that I can send to the machine. So first thing we're going to do is face the part. We're going to call it facing, and then we're going to say that we both want to rough and we want to finish cut the face with the same tool. Z-axis coordinate of the finish face is 0. So basically this is a fill in the blank form. I'm going to fill in the blanks and I'm going to create the G-code to face the part. The diameter of the stock is 1.25 inches. We're going to take 1/8 of an inch off the front. We're going to do that at 50 thousandths depth of cut. The smallest diameter is going to be all the way to the center line, so 0. We're going to use 50 thousandths of clearance. The finish allowance in Z, we're going to use 5 thousandths. So what it's going to do is going to rough the part, leaving 5 thousandths, then come back and finish the part. And now we need some speeds and feeds. So what we do is we use the wizard that comes with the software. So what I can do is I can say that it's 4150 steel. I'm using carbide. We can set this up inside of the wizard. Right now we're using just the defaults. I'm going to calculate it, and then I'm going to record it, which is going to automatically put my speeds and feeds into my form. When I create the program, I'm going to create a longhand program. It's going to put it up in the tree, and so I've created my first operation. I can pull this back at any time, look at the conversational screen, make any changes that I want to make, and update that particular cycle as I go along. Next thing I'm going to do is I'm going to create the turning program. So I'm going to use the simple turning menu. So taking a quick look at the part, we're basically going to describe 3 corners, 1, 2, 3. This is the furthest corner away from the part face. This is the corner that's automatically formed between corners 2 and 3. So we're going to describe the X coordinates, Z coordinates, and chamfers on those 3 corners using this conversational screen. So diameter A is going to be 1.25 inches. The coordinate is going to be -1 inch. Diameter B is going to be the 5/8, and that's going to be at 0. So now we have 1, 2, 3. Corner 1 and corner 3 both have chamfers on it. So we're going to tell it that we want a chamfer. The value is going to be 1/8 of an inch by 45 degrees on corner 1, and same thing on corner 3, 1/8 of an inch, 45 degrees. And then we can add this to the elements. Basically that's all we need to do for this particular part. We could have an unlimited number of diameters that we want to turn. We only have 1, so we're done actually describing the part in the top section of the form. And now what we're going to do is describe the machining. So we're going to use 50 thousandths for clearance in X and Z. We're going to take 100 thousandths depth of cut. We're going to leave 10 thousandths for finish. We're going to retract the tool by 50 thousandths each time. And again, now we need some speeds and feeds. So we're going to go back to the wizard. We're going to tell it we're going to use 4150. We're going to use a carbide insert, calculate it, and record it. And now we've got our speeds and feeds. Just to make things simpler, I'm going to just rough with this tool, then come back and finish it with another tool. So I'm going to leave this as rough turning. We could also do rough facing, which is going to bring the tool down in X. We're going to do rough turning, so I'm going to create the program longhand G-code. And then what I want to do is I want to copy this so I can finish it, so I don't have to create it from scratch. So I'm going to say finish turning. I'm going to double click to open it up. I'm going to turn off turning, turn on finishing. Go get some speeds and feeds. 4150, carbide, calculate, record. So now I've got some speeds and feeds to finish the part, and then I'm going to create the program for this. So I'm going to take a quick look through using Kipware TP as to what the toolpath looks like. So I'm just going to automatically going to load the programs. There's the roughing, there's the finishing. Let me just blow this up a little bit more. Of course, the picture is not quite as good as Fusion360, but it's very quick. It's down and dirty, tells me how the part is going to get machined so far, and that's exactly what I'm looking for. So I'm going to go back to TP and continue. So next thing we're going to do is we're going to do the groove. So I'm going to do the OD shoulder groove and fill in the blanks. So the Z coordinate of the back edge of the groove is 1 inch. The width of the groove is 130. The width of the grooving tool is 1/8. We're not going to use, let's say, 10,000 step over. The front diameter is the thread diameter of 5/8. Rear diameter is 1.25 inches. The groove diameter is 425. I'm going to leave that blank. I'm not going to peck it. I'm going to use 50 thousandths of clearance. Oops. Finish allowance on the sides, I'm going to use 1,000th. Thousandths on the diameter. I'm going to get some speeds and feeds from the wizard. So 4150. Use a grooving tool, calculate it, and record it. I'm going to finish it as well, so I'm going to rough it and finish it, and then I'm going to put a chamfer on this side. Corner 2, corner 1 already has it from when I turned the part. Corner 2 needs a 30 thousandths by 45, and so we're going to create the program and add that to the tree. Let's just take a quick look at how this looks in the plotter. And you can see that we've got the groove. With our 30 thousandths by 45 in the back. So looking good so far. Last thing we need to do is thread it. So I'm going to use the OD threading menu. I'm going to use a can cycle. I've got a straight thread. It's right hand. So the Z coordinate of the front edge of the groove is 0. Of the thread. The length of the thread is 1 inch minus 130. Which is 870 would be to the end, so I'm going to go 890. The OD of the thread is 5/8. Clearance amount, we're going to use 50. Number of threads per inch, so it's 11. Automatically calculates my thread depth for me. The clearance to start threading, I'm going to use 100 thousandths. Clearance at the end, 0. Number of finished passes, I'm going to give it 2. Depth of the first pass, I'm going to go 15. It's a 60-degree thread. So you can see from the fill in the blank forms, it's just basic machining inputs that we need. I'm going to go get some speeds and feeds. And that should create my thread for me. So 1375 90 thousandths per rev, which is based on the threads per inch. Again, we got the depth already calculated, so I'm going to create the program, and I've got the OD thread done. So what we've done with Kipware T is we've created all the cycles to machine the part. Facing, rough it, finish it, groove it, thread it. All of those are done. Now I can go and do what we call create a main program. So you'll notice in the cycles we didn't call any tools. Now we're going to link tools in the turret to the actual operations that they're going to machine. So we're going to use tool number 1. So first operation, tool number 1, offset number 1. We're going to use a starting point somewhere near the part. So the part's going to be, say, 2 inches in diameter and 1 inch in Z. So we're going to use this as our starting point, which is basically the indexing position of the turret. First thing I'm going to do is I'm going to face it, but then I'm going to rough it with the same tool. So I'm going to link 2 of these cycles to this one tool. So I'm going to face it, I'm going to turn it. Next, I'm going to use tool number 3. I'm going to use my 2 inch and 1 inch as my point of index, and I'm going to get the finish turning. Then operation number 3, I'm going to use tool number 5. I'm going to use my 2 inch and 1 inch, and I'm going to do the groove. And then operation number 4, I'm going to use tool number 7, 2 inch and 1 inch, and I'm going to do my thread. I'm going to give it a program number. I'm going to select a Fanuc post processor, so my code will come out in Fanuc code, and I'm going to create the G code. So here it is. We've got the G code to machine the part. Rough turn it, face it, rough it, come back, finish turn it, come back, groove it, and then come back and thread it. So in a little less than 10 minutes, we've created the program, the G code program we can send to the machine to machine the part. So now that we've illustrated the programming process between CADCAM system and Kipware T, we're going to take a look at the programming comparison breakdown. First of all, we had to create a drawing. So in the CADCAM system, basically took us about 10 minutes, and in Kipware T, we needed not to create a drawing, so that's basically not applicable. Next, we had to select and create a stock model so that we could describe the machining to the CADCAM system. It took us again about 2 minutes, and in Kipware T, it was not applicable. Next, we selected tools and created operations, basically creating the toolpath and the operations to machine the part. About 15 minutes in Fusion360. And in Kipware T, this is basically the whole programming process, is describing the operations, creating the tools. So the whole process of creating the G-code program in Kipware T was about 10 minutes. Next, in the CADCAM system, we had to post process and create the G-code. That took us about 3 minutes for it to run through in post process to actually get a G-code program. Again, in Kipware T, when we finished the program, we had the G-code. So the total time in the CADCAM system was about 30 minutes from drawing to G-code. And in Kipware T, it was about 10 minutes. Overall, if we consider a $20 per hour labor rate for a CNC programmer, which is fairly low, I think, in the industry, the programming cost to create this particular program was $10 using Fusion360 or a CADCAM system. In Kipware T, the programming cost was $3.33. Again, if we consider a $20 hourly wage, if we consider that we create 3 of these types of sample programs per week, the yearly cost savings between a CADCAM system and Kipware T is almost $1,050. More importantly, the yearly time saving between using a CADCAM system and Kipware T Conversational to create this type of sample program is about 78 hours. So the programming time is going to save 78 hours per year if you make 3 programs a week using a conversational system versus the CADCAM system. If the message in our video makes sense, we invite you to get the full details of Kipware Conversational at our website, kentecinc.com.